Hello, everyone. Welcome to the ETAP Real-Time Intelligent Load Shedding Case Study for B.Braun Medical. My name is Eric Ham, and I am a Senior Automation and Controls Engineer. I've been a part of the ETAP family for a little over 10 years now. Along with the ETAP team, we were able to successfully execute and deliver the ETAP ILS solution for B.Braun. B.Braun Medical is a manufacturing facility of medical products. The plant is powered by two switchyards, Switchyard A and Switchyard B. Switchyard A has three sources that run seamlessly to provide power to most of the facility. Source 1 is a generator that provides approximately 2.7 megawatts. Source 2 is another generator that provides approximately 3.3 megawatts, and the rest is carried out by the grid, which is approximately 1.6 megawatts. The second part of the facility is powered from Switchyard B. This switchyard is only currently connected with the grid. B.Braun is in the progress of installing a new on-site generation to this switchyard. While the on-site generation is being commissioned, ETAP is also working on an ILS system design. This would help maintain the critical loads to prevent any damage physically and financially to their electrical network. With ETAP's digital twin modeling capabilities, we are able to clearly distinguish the two different subsystems and validate them through ETAP. This helps support the foundation of ETAP ILS for the second half of the plant, thus making the implementation of ILS effortless and seamless. Switchyard A energizes 12 substations and a few large chillers. The majority of the facility is powered from this switchyard. ETAP ILS was initially implemented for Switchyard A. Switchyard B energizes 4 substations and a couple large compressors. For B.Braun, the load category for both switchyards range between non-critical, semi-critical, and critical loads. Non-critical loads are the lowest priority, which will be chosen by ETAP to shed first. These loads are always to be shed. Semi-critical loads are medium priority. These loads will be chosen if the non-critical loads are insufficient to meet the load shedding requirements. Critical loads are never to be shed. This means that they are either not connected physically or disabled from ETAP. With ETAP ILS, B.Braun's ability to make changes to load priorities are flexible and simple. Load priorities can be modified through ETAP Load Shedding Manager at any given time. In addition, it will not affect the live production of the system. At B.Braun, the existing load shedding scheme was compiled of relays and timers. There was no intelligence to how the loads are being selected to be shed. Each time a disturbance occurred, all loads that are connected were shed. This means that during an outage, critical loads and non-critical loads are shed. This event causes loss of production, revalidation, and resources to re-energize the facility. The scheme lacked the functionality to determine the necessary and optimal load shedding scenarios for a disturbance. This resulted in an unsafe operating condition and costly outages. The ETAP ILS solution at B.Braun provides a quick response to an island condition. It will constantly monitor the operating condition of the electrical network and load shed only loads that are necessary to maintain the system during an island condition. ETAP ILS will only shed loads that has been configured in the ILS configuration. The entire process will ensure that the plant's critical operation continues to operate while the non-critical loads are being shed. In recent years, B.Braun facility has experienced several unplanned outages due to the instability in the facility's electrical network. The facility's outages were typically caused by undervoltage disturbance. Some equipment was able to ride through the undervoltage, but most of the equipment could not. This led to the entire facility and process going into an outage. Due to the strict manufacturing regulations, the process that were shut down will have to be revalidated to ensure cleanliness and accuracy. This typically takes hours to complete. ETAP was able to provide a successful and effective ILS solution to B.Braun. With the optimization from ETAP ILS, load shed was successfully executed during an island scenario. The solution provided both a continuous calculation and optimal load selection of B.Braun's system. Prior to an event occurring, ETAP ILS is already predicting and calculating the loads to be shed. This allows ETAP to act instantly when a disturbance is happening and executes rapidly. ETAP ILS dynamically generates a predefined load table that is constantly updating. It is also sent to the load controller at each time there is an update. This allows ETAP ILS to execute load shed in less than 20 milliseconds, which minimizes the disturbance to the other processes at B.Braun's facility. Prior system provided no optimization of load shedding. When load shed is being executed, the loads would be shed in sequential order. Simultaneously, the loads that are connected were all shed. B.Braun had no process selecting or removing loads from an operation standpoint. All equipment and integration work were required to be done manually at each substation. ETAP ILS is a powerful and effective solution to be integrated to the B.Braun electrical facility. ETAP was able to provide load optimization and load priorities to the system. In an event of a load shed will shed close to the required amount with a deviation of 3% max. This allowed B.Braun to work on the ILS system through ETAP to identify which load would be shed and shouldn't. In addition, all changes are made in ETAP, which eliminates the requirement for B.Braun to work on the system manually. ETAP benefits the B.Braun system tremendously. Being able to validate the electrical system into two subsystems allows the ILS solution to be precise and effective for each switch yard. In addition, no critical process interruption is affected by the grid disturbance. An additive benefit for B.Braun was the visibility of their electrical network. With ETAP ILS, a HMI was developed and deployed. B.Braun now can visually monitor each substation and the loads available, including breaker statuses. When a disturbance does occur and ILS is executed, restoring the system is clear and understandable. In conclusion, the ETAP ILS solution for B.Braun eliminates the impact from the utility disturbances. While there is a disturbance, ETAP ILS allowed B.Braun to operate safely in an island scenario. The solution helped B.Braun minimize the loss of critical processes during an outage. ETAP also provides a validation tool for future upgrades and expansions to the electrical system. ETAP ILS is a powerful, flexible, and user-friendly load shedding solution. For B.Braun and other systems that have multiple operating, generation, and critical loads that require a non-interrupted operation, ETAP ILS is a must. Thank you for listening.